Hello everyone, I'm Asudha, Assistant Professor, Department of Electrical and Electronics Engineering, Thandai Periyar Government Institute of Technology, Vellore. Here I'm going to explain you the power system subject through e-learning. Course objective. The main course objective is to model the power system, the steady state operating condition, to understand and apply iterative techniques for power flow analysis, to model and carry out short circuit studies on power system, to model and analyze stability problem in power system. Let's see what we are going to see in the first unit. The first unit is about power system. Here we are going to see the need for system planning and operational studies, power scenario in India, power system components and its representation, single line diagram, per unit quantities, per unit impedance diagram, and per unit reactance diagram. We are also going to see the network graph, bus impedance matrix, primitive parameters, bus admittance matrix from primitive parameters, representation of off-nominal transformer, formation of bus admittance matrix of large power network. Introduction. The electrical energy is generated by converting the other forms of energy available naturally. Controlling of electrical energy, transmission of energy over the long distance to different load center, and distribution and utilization of electrical energy together is called an electrical power system. The need for system analysis in planning and operation of power system. Let us see what is the need and how we have to plan to construct a new power system. Planning is an essential part of any design and implementation process. Before start of new plant, estimate the needs of localities, load required to be serviced by the plant. Select a proper site, layout and location of control and switchgear, etc. Check if the plant needs to be integrated into the overall grid system. Plan for expansion of plant in future if need arises, and a provision has to be made. Transmission and distribution lines also has to be planned in advance. This can involve transformer, line layout and many other factors. So in short, unless there is a proper planning, no effective and economic system can sustain. What are the current power scenario in India as on 30/4/2020? The total installed capacity based on state, sector and private is shown here. Let us see what is the central sector is giving the power. The central sector power is about 93,477 megawatt, which is about 25.2% of total installed capacity. The state sector is 1,03,322 megawatt, which is about 27.9% of total capacity. Private sector, which has a power capacity of 1,73,549 megawatt, where the 46.9% of total installed capacity is given by the private sector. Hence, the total is 3,70,348 megawatt of power. Let us see how and where the powers are coming from. The maximum power is through thermal. What are the different fuel which is in thermal are coal, which gives the capacity of 1,98,525 megawatt, which is about 54.2%, lignite, which is of 6,610 megawatt, it is around 1.7%. Gas 24,955 megawatts, it is about 6.7% of total. Diesel 510 megawatt, it is around 0.1%. So the thermal is around 2,30,600 megawatt. The total of thermal is 62.8%. The remaining hydro, which is a renewable energy, is 45,699 megawatt. The percentage is 12.4. Whereas the nuclear, which gives the power of 6,780 megawatt, which is about 1.9%. And the renewable RES, which is from MNRE, it is 87,269 megawatt, 23.6% of total installed capacity. So the total power is 3,70,348 megawatt as per the data taken from Central Electricity Authority. Before we go inside the subject, let us see what are the main components of power system. The first and foremost component is a generator, transformer, transmission lines, distribution line, load, compensating devices such as shunt compensator, series compensator, static VAR compensator. Modeling of generator and synchronous motor. The generator is designed by the voltage which is generated is given as EG, internal resistance is RA, armature resistance, and the reactance is JXS. See the direction of current. The current is taken from the generator. This is the equivalent circuit of a generator. Let us see what is the equivalent circuit of synchronous motor. Motor takes the current IM, flows through reactance and armature resistance, and the back EMF is EM. Now let us see what is the transformer modeling. Transformer has two sides, one is primary and secondary. The primary current and voltage are I1, V1. Resistance and reactance are taken as R1 and X1. Similarly, the secondary voltage and current is V2, I2. And the resistance and reactance are represented as R2 and X2. Here in this, the secondary components are transferred to primary side and it is represented by using the transformer ratio. This is V1 and this R0 and X0 are nothing but your no loss component. I1 is the primary current, I2 dash is your current which is referred to primary side, R01, X01 and V2 dash. Let us see what is R01. R01 is the vector addition of R1 plus R2 dash. Here R1 is your primary resistance, R2 dash is the equivalent resistance which is referred to primary side which is given by R2 divided by K square, where K is nothing but your transformer ratio. Similarly, the reactance, total reactance X01 is nothing but X1 plus X2 dash. X1 is your primary and X2 dash divided by K square is the total reactance referred to primary side. Modeling of transmission line. There are two ways we can model the transmission line, either by pi type or by T type. A transmission line which comprises of resistance, inductive reactance and capacitive reactance. This is a modeled network shown for the transmission line in pi type. If it is of T type modeling, it is shown in such a way. Now let us see how to model the induction motor. Of course, induction motor is nothing but your stationary transformer. When it comes to a rotating transformer, it will be a working as an induction motor. So the equivalent circuit is similar to that of the transformer. But here it is a rotating transformer, so the effect of slip comes into play. Here, similarly, like how we have done in transformer, here the transformer and has primary and secondary. Here in induction motor, it has stator and rotor. So the total resistance is given by stator resistance plus rotor resistance R2 dash, and this R2 dash is again referred to the stator side. R dash divided by 1 by S minus R. This S is nothing but your slip. Now the reactance is the summation of stator reactance plus your rotor reactance, which is total of your equivalent reactance referred to stator side. Let us go for the next topic, which is a single line diagram. What is single line diagram? Why we should go for single line diagram? In practice, the electrical components consist of much and more components, and of course the electrical power system is very complex and the size is unwieldy. It is very difficult to represent all the components on a single frame. The complexity could be in terms of various types of protective devices, or it can be a machines such as like transformer, generator, motor, etc. And it can also be either the connection types, whether it is a star, delta, etc. and etc. Hence, for the purpose of power system analysis, a simple single phase equivalent circuit is developed called as one line diagram, or otherwise it is also called as single line diagram. So an SLD is nothing but a pictorial representation of entire power system from generating end to the consumer premises is known as single line diagram. Let us see what are the symbols which we use in SLD. The various symbols are used to represent the different parameters and machines as single phase equivalent on the SLD. Some of the important symbols used are listed here. The rotating machine is usually represented as the circular, where the bus, which is represented as the line which has the interconnection of this. A two-winding transformer, which is present as a primary side and secondary. The delta connection, it is for three-phase, three-wire, which is shown in the form of delta. Star connection, where three-phase, neutral, ungrounded. So without neutral, it is a three-phase, three-wire system. The symbol is shown like this. The next comes the star connection with neutral, grounded. So it is a three-phase, four-wire system. A simple transmission line is represented as a straight line. And this is the static load. The symbol for static load. This is the simple example to show the single line diagram of power system. This single line diagram has only one bus. This is a representation of bus. To this bus, there are three generators G1, G2 and G3 are connected. This generating station's voltage are stepped up by using the transformer T1, T2 and T3. The stepped up voltage is transmitted and this transmission line is shown here. Now everything is connected to the bus. This transformer is delta star with 4-wire, neutral, grounded. Here, see here, since the generator is of star grounded, the primary of this transformer is star grounded and the secondary is star ungrounded. This is of transformer delta and star ungrounded. So a single line diagram comprises of generator, transformer, transmission line, bus, etc. With this, let me stop and we'll see the next topic in next video. Thank you.